Okay, so what I want to talk to you about today is a little bit what we talked about at the end of that introduction, which I really appreciated, and this idea of democratizing data and how we bring the skills and perspectives that we talk about in this meeting to more people to have an impact in science and society and empower the people who have questions to ask for them to be able to ask these questions themselves. So I want to start out, though, by thinking about, in this community, some of the things that you're most excited about, if my slides will advance. So the question is, there we are. What are you most excited about working in scientific Python or programming? So think about it for a second and then turn to the person next to you, introduce yourself to them, and tell them what are you excited about in working in scientific Python or programming. And I'm going to clap to bring you back together because this is going to get loud. Okay, so go ahead, talk to your neighbor. What are you excited about working in scientific programming? Okay, clap once if you can hear me. Clap twice if you can hear me. Clap 3 times if you can hear me. Okay, so when you talk to your partner, those of you who have computers, what are some of the themes that came up? You can go to this URL and enter them in. It only takes 50 responses, so the first 50 people to put them in. So what are some of the things you heard when you talked to the person next to you that people were excited about? It's still there, hopefully. Come on, computer. Okay. It's supposed to have a word cloud here. Well, I'll put this in, but it's supposed to generate a word cloud of the things that you're excited about. So some of those things, though, that we've heard in the past. There we go. Excellent. I knew it would work. It's all about the software. Right, so some of the things that people are excited about: learning, data visualization, pattern, tools. I love that learning is there. Big in the middle, community code, growing, right? So development, easy. I'm interested in the easy one there. Right, so a lot of words about the growth and the potential that you think about when you think about working in scientific programming. So now talk to the person next to you again. And instead of talking about necessarily what you're excited about, what are some of the things that frustrate you about working in scientific programming? And there's no fill in the poll here, so no one will see what you're going to say here. Okay, clap once if you can hear me. Clap twice if you can hear me. Clap 3 times if you can hear me. Okay, so we'll skip the poll. But so what we see is that it's not necessarily, it might be some of the data and the tools that just came up as a theme around frustration, but a lot of it is how we do that work. And so we're excited about the potential of these skills, but there are some things that frustrate us in the ecosystem. And part of that is how we've emerged, and I'm going to use the words data science, not to mean anything in particular, but sort of the general effort around working with data in science and in research and to solve other problems in society. And so as data science has emerged as a field, and we really see this. I was reflecting on, having spoken here 4 years ago, and just 4 years ago, the growth is just amazing. It was 4 years ago that Fernando, in a lightning talk, Perez announced about Jupyter, changing IPython to Jupyter. And we see now that across our ecosystem. We see the development of tools like Pandas, the Tidyverse, and R that are making it easier to work with data frames in these programming languages. We've seen all kinds of amazing things about visualization. There's so much that has created opportunities in these last 4 years. But we still sort of have this model of having a Wonder Woman in data science that is going to solve all of our problems. So we look to hire this person in our companies or in academia as our postdocs, someone who knows all of the domain, who knows the full stack of the software, who communicates with other people, and that's amazing, and these people do exist, and we should value them. Please say thank you to your Wonder Women in your midst. But that only scales so well, right? And not every problem requires a Wonder Woman. Not everything is a crisis that requires her to come in and save the day. What if instead we can think about bringing more people to computing that can answer some of the questions that we have in front of us that don't necessarily require everything that Wonder Woman brings to the table? So we talk about bringing compute to data or data to compute, but we really need to bring people to data. So how can we scale the number of people who can work with data along with our data production, right? Another thing that has changed in these past 4 years is the amount of data that we're generating, right? We started with a few industries. Now almost all industries are generating data, looking at how they can use it. We heard some great examples about in healthcare, in smart buildings. We're thinking about it in humanities and social sciences, as well as genomics and astrophysics. So how do we scale the number of people that can work with this data that's available to us? And so I'm going to talk about 3 approaches that help bring people to data. So that's tools, training, and community. And I'm going to start with tools. And I'm going to talk about tools not necessarily from the perspective of everything that we're talking about in this meeting and the lines of code. There's kind of this idea that pervades because of how people view the internet as software as a service, right? A lot of companies, they're developed with this model, right? And that's a great model for a lot of things. But research-driven software, software developed in the pursuit of a research question, is fundamentally different than software as a service. In software as a service, the number of people with the problem is many, right? You can't build a business, usually, if you don't have many people with a particular problem. The understanding of the problem is usually pretty good, right? There's a lot to figure out, but there's a general sense of the problem. The need for the users to understand the software implementation is low, right? It's not important for people when they're using it to understand how it's implemented. You could argue against that, potentially, but in general, that's true. This contrasts with research-driven software, where the number of people with the problem is 1 to not that many. In some spaces, it might be a lot of people, and we see a lot of general packages. The understanding of the problem is typically pretty low at the start. We don't necessarily sort of know what we're getting into when we develop the software. We're developing the software as a part of solving the problem. And the need for the users to understand the software implementation is high. Right, we can't obfuscate the details when we're developing scientific software for the sake of reproducibility and scientific progress. So I want to think about the tools in a way of software not as a service. And what does that mean if we think about software not as a service? It means that we change our thinking about tools being just lines of code to valuing the skills and the people as integral to the research process. I am preaching to the choir here, I know. And so that's from two different perspectives, right? So there's the developers, and I want to talk about how we can think about valuing developers, but it's also the leaders. And we'll refer back to Ralph's great talk from yesterday morning. So first, let's talk about the developers. We envision them as these happy people. No, we don't really envision them this way. But maybe other people envision developers as, you know, happy people coding in their labs or whatever it is. But instead, probably this more reflects the reality, whether you're upset with your lines of code or just your general state of being. So how is it that we can think about valuing developers? And I am going to talk a little bit in an academic environment because that is where a lot of the scientific code comes from. So some of the incentives might be different in an industry setting, but the general ideas hold. So the first is giving credit for software and good software development practices. So we know that in academia, the software itself is not valued in the same way as a research paper. And so one thing is to start treating software as a research product. And I'm not going to talk about changing academia because I don't have that ability. If you have that ability, please just go do that. Put it top of your list as a priority. But that's something that we can do. But along with valuing, giving credit for software is valuing good software development practices, right? When we see the software as service to the research, the idea is get the software done as quickly as possible and give me the answer. It doesn't value the process of doing the development and the work that you need to put into making good code that you can share, code that's documented, code that's reproducible. All of those things need to be valued as a part of the research process rather than a service to the broader mission. Career paths for research software development, so this is the sort of change academia part that I think there's a few people working on, and I'll talk a bit about that. Information or access to resources on better and best practices. So I think in this room, what's great, and we've seen this in a lot of talks, there's a lot of great resources on how to do these things well. But what happens is that we learn them by ourselves over and over again. So where are resources that we can go to as developers to look for guidance on best practices? A checklist we can use when we're developing our software, or those templates. Oh, that cookie cutter thing was awesome, right? So something like that. So we saw a talk yesterday on cookie cutter where you could just go and get basically the whole infrastructure for how you would want to put together your project, right? Everybody's sort of learning that on their own. Those kinds of projects really make a big difference in the learning curve and the good practices. And finally, pay for open source software development. So I like this. This is a good audience. So to the first couple of points around getting credit for software and career paths. So the Journal of Open Source Software, and there's a lot of the people that founded this project here, is a journal that you can submit your software to. So it rewards good practices in software development. You submit your software if it has documentation and tests and a README and a license. You submit your software with a brief description, and that becomes a publication. I think we're over 200 publications now in the Journal of Open Source Software. So that's a way of giving credit for software through the paper and publication system. So it's, you know, maybe a little bit of a hack, but it's another way of demonstrating the value and getting credit for the work that you do. Then in terms of thinking about research career paths and also some of these other things around things like this credit through documentation or through these journals is the Software Sustainability Institute in the UK. They've done a great job creating research software engineering paths in the UK. And there's a complementary effort that's at the conceptualization phase in the United States, ERSI, that looks to do a similar thing within the United States and looking at the landscape here and what's the potential in academic institutions for these as career paths. Similarly, the Moore and Sloan have funded some data science environments at Berkeley, NYU, and University of Washington to explore these ideas of creating opportunities for data science and programming within universities. And they've developed differently at the different universities, and there's some great blog posts coming out of there talking about sort of the different challenges and opportunities through that system. But to the point which you appreciated in paying people for open source software development, so this is really important, right? Because I was just at the Bioinformatics Open Source Conference meeting a couple weeks ago, and Fernando Perez was also giving a talk there. And this is a point that he made. You know, when people are expected to work on open source for free, only the people who can afford to work for free can participate, right? And so it's a real privilege to be able to work in open source, right? And we need to create opportunities for people who don't have that time to work for free to be contributing to this process, or the people who are working for free, who value this as their important work, to get paid for this work. So it's really, you know, there's no easy solution here. It's been great to talk to people here and talk about this as an idea, but we can't keep thinking that this work is free because it limits who's involved and it limits the sustainability of anybody working on these projects. So leadership. So that was the other piece of talking about tools. So we talk about lines of code, we talk about developers, and I thought, you know, Ralph talked yesterday about the path to SciPy 1.0. And a lot of that path to SciPy 1.0, some of it was about lines of code, but a lot of it was about leadership. And he was talking about, right, that time when he disappeared from his email, which I think we all want to do, and that he needed to just take that step back. We are all sort of familiar with these pyramid of maintainers, and that you have only a few people at the top who are helping to maintain the code. And that's sort of natural, right? You're always gonna have kind of a pyramid structure in any of these things. The thing though that we're not doing is we're not valuing that leadership level. A lot of our maintainers are working for free or as side projects. Maybe they are getting paid at a company, but on 20% time. And so it's not only valuing these people and potentially paying them for their work, but training them to be leaders, right? We all come in as software developers, and that transition from being someone who's contributing to a project to maybe this approvers, maintainers, what does this pathway look like? How do we help make that easier for people? How do we train each other? This is another situation. I think we're doing a lot better job around helping train other developers, sharing resources, sharing code, offering training. But what we're not yet doing is supporting each other in these leadership roles. How do you become a maintainer? How do you think about it? How do you have your backup maintainer, right? I think that we're at a situation, and maybe this is one of those things that people have been saying this for 10 years, but where a lot of the people at those maintainer and those chief maintainers are essentially burning out. And that's going to really have a big impact on the projects that we all care about. So how can we support those leaders, help them in their jobs, and bring up new leaders in our community? Because I know, like, everyone I've talked to here is a leader in this space. You all have opportunities to do these things. If that's something that you're excited about, you should be able to be supported in that pathway, as well as being supported in writing lines of code. So the second part of the triangle is training. And with the carpentries, this is, of course, near and dear to my heart. And so one thing that's really interesting about current researchers, and we'll talk again about the research space, is that they have actually many of the qualities of the superwoman, right? They understand the research problem. They have the ability to learn new things. They're motivated to answer the questions. What they don't have is computational skills. And that's off because they haven't had the opportunity to learn them. If you're a postdoc, you know, it wasn't even on the radar when you were an undergrad, potentially even a graduate student. There weren't training opportunities. Even now, if you're an undergraduate, there aren't a lot of opportunities outside of, say, you know, computer science or sort of traditionally considered computational fields to learn these skills. The Berkeley Data 8 program is one that's emerging and now on Coursera. But most universities are still trying to figure out how to implement something like this at a broader scale. And the great thing, though, about these folks is that They're also very motivated. They really want this training, right? So this is a survey of Bioinformatics Resource Australia, and they asked, what is the most useful thing that we can do? And 50% of respondents said offer training. And this is one of the few plots I've ever seen where something is more important than funding. And so this is something that, we're not trying to come in and say, you need to learn these things, right? This is something that people want to learn. They're looking for opportunities. Similarly, a survey in the United States of PIs at the National Science Foundation on biology projects. They said, what are the current unmet needs? So the font's a little bit small here, but the top 3 of these are training. So we have a community of people who are excited about the potential to learn. So how do we offer this training? And because we've talked about undergraduate curriculum and that is still sort of catching up, but also because a lot of the people that are here, right, they're active researchers. They don't have time to take a semester course. So we need to think about training in the gaps. And what does training in the gaps mean? It needs to be accessible and aligned. So by accessible, that means a lot of things. It means accessible at your location. It means accessibility in terms of accessibility requirements and being accessible to all people. It means accessible in terms of the time that it is. Does it need to be weekends? Should it not be weekends? So it needs to be training that's accessible to you when you need it. And it needs to be aligned. It needs to be aligned with the problems that you're facing, the things, all those questions about being motivated. It needs to be aligned with the motivation that people have to learn these skills. And so that can be different in different domains of research, at different career stages. So we need to think about these training and the gaps opportunities as meeting these criteria. So some of the ways that we can do training in the gaps are workshops, short courses, self-guided learning, MOOCs, integration into existing courses. And I'm going to talk about, there's a lot of great options in lots of these different areas. I'm going to talk about workshops because that's what I know most about from the carpentries, and also because we've shown that they really have an impact. So I really appreciate the introduction this morning and that kind of qualitative sense around the impact that these workshops and the carpentries have had in people's lives. So I want to talk a little bit about how we do that and the impact that we're seeing. So in January 2018, Software Carpentry, which was founded by Greg Wilson, and Data Carpentry, which was founded later in 2014, merged to become the Carpentries. And so we're now a joint organization teaching foundational coding and data science skills for researchers worldwide. And we talk about our training, but you'll hear it's also really about our community. And I think as we've grown, what I'm really excited about with the joining of the organizations is not so much about the curriculum, but the building of the community and contributing to build a broader community around these practices in lots of different domains of research and different tools. So with the Carpentries, we teach core skills for effective research computing. We have trained instructors, volunteer instructors. Our general format is 2-day hands-on workshops, and we use collaboratively developed openly licensed materials. So the first piece around the collaboratively developed openly licensed materials. So Greg started out Software Carpentry, and he started out these lessons in this way. In having all of the materials online in GitHub repos, essentially like a software project. So all of our lessons are online in GitHub, and so you can contribute to them in the same way that you would any software project. You can file issues, create pull requests. So most of our lessons have hundreds of contributors. And because we teach them so frequently, different people are seeing them and using them, so they have a lot to contribute to how things change. So it keeps them relevant. So this model around collaboratively developed openly licensed materials has really allowed us to scale the numbers of lessons that we have and maintain their quality. So we now have over 41 lessons, including a recent translation into Spanish. And so what's really great about this is that scalability. It also means that we have essentially 41 open source projects that we maintain as a part of the Carpentries. Volunteer instructors. So when I talk about community, this is really the core of the Carpentries. So last night we had the opportunity to have dinner together, some of the Carpentries folks, and people are spread all over the world. So it's always great to get to meet with each other. And so we have an instructor training program that trains people in how to teach. So this is part of that scaling, is that we're investing in people and people are investing in each other to spread the ability to teach these skills as well as the kinds of curriculum. So you can see some familiar faces in this particular photo. Katie Huff, last year's SciPy Keynote, and Matt Davis, now at Clover, one of the organizations sponsoring the diversity lunch. So the Carpentries have really been tied to the SciPy community for a really long time. And so we still really see this as one of the conferences that's the heart of our program. Oh, and there's Anthony too. So look at that. That looks just like him when he's up here too, right? So since this started, so Greg restarted this in 2010, we've really grown our workshops. You can see now increasing every year the number of learners that we're reaching, and we have a global community now as well. So these are workshops where we've taught all over the world. We finally taught on the 7th continent in Antarctica, so now we've taught on all 7 continents. Yes. It's really one person, Harriet, who gave that, and I feel like she should always just get the credit for that. It was a 2-day delay because of weather, so I was like, so sad you can't get home to see your family, but could you teach a workshop while you're there? So that's been really exciting, the global reach, and just last night, Malvika was talking about bringing more to Argentina. So people take the Carpentries with them to different places, and it's able to have a global impact that way. So these are just kind of some numbers around our impact. We have 1,480, more than that now, instructors. We've taught 1,332 workshops, 37,000 learners in over 44 countries. And so those are just the numbers of who we reached. But the question is it having an impact? So we do both short-term and long-term studies, surveys of our learners. So we do a pre-workshop survey and a post-workshop survey. So that's to get people's ideas around the workshops and also around what they've learned in those 2 days on the short time scale. We also follow up with a 6-month survey, so 6 months after the workshop, to see if the kinds of things they learned are still persisting, if they still saw it as a valuable experience. Maybe it was just a great 2 days. And so right after the workshop, we see that 77% are more comfortable with the tools. This is the long term. So this is, when we talk about the 6-month survey, 6 months after a workshop, 77% of the respondents are more comfortable with the tools than they were before the workshop. 54% say they have made their analyses more reproducible. 65% have gained confidence in working with data, and 74% have recommended the Carpentries workshops to friends or colleagues, or say they would recommend them to friends or colleagues. And so this evaluates, you can see we're not asking like, can you write a script, right? What we're talking about is, do you use these tools and do you feel comfortable and confident using them? Because if people don't feel comfortable and confident using the skills, they're not going to use them. So in our 2-day workshops, what we really focus on, we teach the syntax, we teach the programming, right? But we can't teach everything about programming in 2 days. So what we do is we try to build confidence for people to go on and continue to learn. Because what we've seen is that a lot of people's first experience learning to program has been a negative one, a disempowering one that made them feel like it was something that they couldn't do. And we want to turn the tables on that and make it a positive experience. So something that people are excited about, something that they feel this kind of self-efficacy, this idea that it's something that they can do. And so when we talk about our 2-day workshops, we use a lot of practices in our 2-day workshops to make that possible. So we try to make them very inclusive and welcoming environments. We have code of conduct for all of our workshops. We talk about using motivational language, not using the word dismissive language like just. We get feedback from learners during the workshops. We use a sticky note system to figure out how people are doing. Green if they're doing well, answered a question. Red if they want some help from helpers. So all the things that we build into the workshop around how we teach is the important thing about the workshops rather than necessarily the content, although the content is important too. And we can see that this confidence persists long term. This is going back to the short-term one. So this is one of these, we now have paired pre and post analysis, so you can match the same person. So we look at some of these things in just 2 days. The top one, it says write program. You know, I am comfortable writing a small program to analyze my data. So before the workshop is the green, and then the blue is after the workshop. So in just 2 days, a full point move in how people feel like they could write some code. That they can search online to find their problems, that they know to keep their raw data raw. We talk about reproducibility practices too. That they can use programming to be more efficient and effective. So those are about perceptions. That they have, they're confident in using more confident in using programming in their work. That they can overcome problems, right? So it's not just about knowing, you know, how to cut and paste, but people are feeling like in just 2 days that I have a better sense of how to overcome their problems. And finally, that they think that these approaches can make analyses easier. So this is really just all an approach to democratizing data skills. So what the Carpentries really does by having this community, the strong community of instructors who teach other people peer-led instruction, building confidence, teaching skills, it's bringing these skills to more people. You can see around the world, Africa is one of the biggest growing areas in the Carpentries right now. We're really, it's an opportunity to democratize these skills. And that's important because it allows people to answer more questions. People have questions they want to answer, data they have. If they have the skills, they can answer the questions that are important to them. We can engage a more diverse set of researchers in computational analyses. We can get more creative approaches and questions, right, by having more people with different perspectives that can bring these skills to their problems. And so really everyone wins. There's like no downside. So our money ball is not identifying underappreciated talent, but creating a program that builds talent. So rather than looking to find the perfect person, if we build a program that creates this talent, not only do we have more people, but we have a more diverse set of people and more questions and approaches that we can use. So finally, the third part of that triangle is community. And this is a picture from our first Carpentry Con in Dublin, Ireland this year, which was amazing. And the community is really key. And I think, you know, that was what, when I came to SciPy, I really felt like I found a community. And it's about that community of practice. And creating a community of practice that is inclusive and accessible. I think one of the challenges in learning to program is that when you go and you look for your community online and you find Stack Overflow, you maybe think this is not a community that is for you. So how can you practice? How can we think about creating a community of practice that's inclusive and welcoming, right? And that requires work and intentionality. These things don't come easily. Opportunities to fail while learning. Right, this goes a little bit to that inclusivity piece, right? So many things seem high stakes. If you're contributing to an open source project, you feel a lot of pressure, right? This is production code, there's people looking at it, or you're just publishing your research code. You're like, oh my gosh, people are gonna read it, see what a terrible programmer I am, right? So how can we think about, you know, opportunities to fail while learning? We're not gonna get this stuff right the first time. How can it be okay to learn and not feel like we need to be best right from the start? This idea of lifelong learning. So I loved at the beginning that learning was top of the list and things that people were excited about, right? Because communities of practice, they learn from each other, right? Local in-person communities as well as virtual networks. And this is something I think in the Carpentries that we're learning. We've had a lot of virtual networks and emphasis on, we have a lot of calls and online resources, but as communities are getting bigger, we're finding that people want to get together locally and connect about things, as well as virtually. And finally, collaboration is key around communities of practice. So open code, open data, open science, all the things that we value as part of being a part of the research process are also just really important in supporting each other, because if your code, even if your code is not perfect, it's an example for someone else, for something that they can try. So sharing how we work and the things that we work on helps our community as a whole. And this is, back to the word cloud. So this is a word cloud from a Twitter analysis of the CarpentryCon meeting. And you can see what people really valued as instructors is the community, right? You can see, this is from actually, and so you can see, things like workshops and things, but the big words are the community and the people. And at the end of the day, as much as we value the lines of code, I think lots of times we stay for the people. And so that community and supporting that community is really valuable and important, and not just an aside. So it's interesting to see the community manager role get more appreciated in open source software. And along with thinking about leadership, thinking about supporting and developing community management and community support. So if we want to go fast, we can go alone. But if we want to go far, we can go together. And I think this speaks to Ralph's point yesterday too, is that when we have, kind of these single people forging ahead, sort of only so far you can go. But if we go together, that we can support each other in these pathways, that it makes a difference in where we can go. And this is a proverb, but I feel like in academia we need to maybe embrace a slightly different model, where if we want to go fast, go alone. If we want to go in a lot of different uncoordinated directions at once, go together. And this is to say that we don't necessarily all need to do the same thing, but that actually by working together we could pursue a lot of different pathways. There's also cute kittens, which is important to incorporate into any talk, especially after nice visualizations. So just coming back to that idea of, what's this triangle? How do we democratize data? How do we scale the number of people that have these skills, that can answer questions that they care about? And so this combination of tools, training, and community, but really all about, at the end of the day, people, empowering people with these skills to do the work, supporting the people who are doing the work. And because we always have data, and we can have tools, and you can turn it into information, but to turn it into knowledge, you need the people that are going to do that work. So I want to acknowledge here at the end here this real sense of going together, I think, in this community, but in the carpentries. So right, this is our global conference. We had 120 people from all over the world come together and really emphasize how important that community was. So I really want to thank all of the instructors, the helpers, the people who've hosted workshops, and helping to bring these skills, this perspective, this confidence, empowering their communities to do their work. And the carpentries also have over 61 member organizations. The Moore Foundation and the Sloan Foundation have provided some grants, and the NSF was helped with initial funding for data carpentry. And so this is, I talked a little bit about the carpentries. There's lots of ways to get involved in all of these elements, right? The Journal of Open Source Software, you can be an editor. With the carpentries, you can be an instructor, host a workshop, become a member organization, donate. You can donate to any of the kind of causes that you see here. You can have workshops in companies. You can do all sorts of different things to be a part of this community, to support these communities. And I'm excited to hear what opportunities and things come out here. We have some more BOFs. We have a BOF this afternoon around data and computing education at 1 o'clock to talk more about these ideas. One of the things people are talking about is bringing these kinds of workshop type things into the classroom rather than everyone writing their own semester-long class, using reusing materials and semester materials. So if you're teaching in a semester-long course, it'd be awesome to have you there and talk about ideas. So thank you to all of you for the work that you do when we say value and contributions. Thank you. Maybe you don't hear it enough, but what you do is driving research, and making innovation possible, as well as maintenance of the important things that do the day-to-day work. So thank you for this opportunity, and thank you for being here and the work that you do.
We have some time for questions. If you raise your hand, I will find you. Or step up to the mic.
Okay. It's working. Thank you so much for the great talk. And I have been wanting to join the carpentry as an instructor for like quite a few months. So I'll talk to you afterwards.
Great.
One thing I want to mention is, this is my first time being at SciPy. I do have this I did have the mental imagery of all the core developers being the Stack Overflow type. I personally had some mixed experiences on the site. And one thing I really want the community to make an effort in is make this message clear, saying we are open source software for science. We are nice. We are really opening to beginners or intermediate levels. We're not one of those coding snobs. And so that I think in the long term that will help the entire ecosystem to be more sustainable. And like I said yesterday, as a user for quite a while, we all have the desire to give back eventually. And also teaching other people really is the best way to improve ourselves too. So really saying that we're nice, we're open, and we need help, and making it really explicit will be really helpful. And thank you so much.
Thanks. So what I heard from that is openness, niceness, and helpfulness equals sustainability. Is that right? Okay. That's the best take-home from my talk right there.
Hi, Tracy. Thanks for a wonderful and inspiring talk. One really interesting point you raised is that as educators, we're training people who are postdocs and faculty members and people who are further on in their careers than perhaps we'd essentially like to be training people at an earlier stage as well. How do we make room in curriculum at an undergrad level, for example, for this type of training?
Yeah, so how do we make room in undergraduate? Well, we're training in the gaps. How can we maybe not train in the gaps? Right, so at an undergraduate level, I like to think about what we can do now, not the aspirational 5 years from now. But what we can do now is we can start to incorporate some of this training into our regular classes. So, right, my background's in biology and genomics. If I'm teaching a genomics course, to start incorporating how do you do genomic analysis into my Genomics 101 course, right? So not needing to create a whole new course, but adding modules to existing course that include these skills. So that's one model. Another is if you do have an opportunity to do a new course, to look at existing courses in similar space and not feel like you need to write all the materials. So Ethan White has a data carpentry semester for biology course. I think Fernando Perez just put together a course last year, upper division course that included testing. So there's a lot of materials out there. Oh, one thing I didn't mention, complementary to the Journal of Open Source Software is the Journal of Open Source Education. So one of the challenges in finding good materials is discoverability. A lot of people have them all over the internet. And so when you type learn R, right, well actually you get DataCamp. But when you type learn R, it doesn't really help you narrow it down. So the Journal of Open Source Education, the idea is that people can submit their educational materials for a publication credit, but that also it lets you find high quality materials in particular fields. So sharing materials, looking for reusable materials, incorporating them into existing modules are three of the things that I think we could be doing now to bring this to undergraduate education.
Time for one more question.
Yeah, well, thank you very much for a really great talk. So I agree with the idea of teaching computational skills as part of the course you're teaching, but sometimes I think you already have a lot to cover in the subject area you're teaching. So why not in a department or across department sit down and look at skills that get into biology, chemistry, physics, mathematics, and then design a course that goes across a course line. Because if we look at computing, so we have different problem sets, but very similar tools. Python, for example, is not only in biology, it's in chemistry, it's in physics, it's in mathematics. So at the foundation, we can have something like that, from my experience. Yeah.
So the question, right, is why, instead of incorporating into a class, you already have a lot to teach in a genomics class, why not look across departments and see what's needed and teach sort of one course. So that's what Berkeley is doing with their Data 8 program. That's actually very rare. So the challenge is this, in that departments have a lot of different ideas about what course requirements can be, so getting departments to coordinate just from a logistical perspective can be challenging. I agree that's the ideal, and I hope that's where we are in 5 years, is that we think about these cross-cutting courses that can be available. Because you're right, absolutely. They're important in every domain, and everyone should have the opportunity to learn them, and you shouldn't require every professor to figure out how to teach them in their course necessarily. So I think that's the ideal. I like to see what different universities are doing around this, but it does require a coordinated effort that I think is still coming together at most universities.
All right, with that, it's time for the break. So let's thank Dr. Teal and all the questioners.